Okay, Derek and Dan, I have added your process properly to the schematic. Now, what I mean by properly, Derek, is that I've now integrated the PDK into the schematic tool. So the schematic tool knows all about what devices you can use, and it just does the right thing. And I've tested it out with a couple of tests. So I've begun with the 18 volt version of the process. So it's now just a process like everything else. There it is, look, the SSI 2 micron 18 volt process. And when you select that process, it cuts down the available devices because, of course, this process doesn't have any, MOSFETs and things on it. Alright, so the way you use it, Derek, now is really vastly simplified. You bring in a device, and if you move the mouse over the name and hit what is called the applications key. Now the applications key, Derek, is the key that sits next to the right hand control key. It's the one that looks like a menu with a mouse on it. And if you hit that key, you will get the list of possible devices. So let's just for fun switch it to that one. Now the resistors are also all of them predefined. Move over the name, hit the application key. Those are resistors that you can use. Let's use a pinch resistor. Let's make it 2 microns 10K, and let's connect up, the world's simplest amplifier just to show you the basics of it. You can see it guesses the names. To rotate, move the mouse over and hit the tab key. Move the mouse over and hit the tab key. In this process, it knows that AVCC is 15 volts and A ground is 0. So again, let's just do something, boring but somewhat useful. Here is a device. Let's stick it in series here. I'll make this a different kind of resistor just for fun. I'll make this an RE resistor. Not sure what an RE resistor is, but a 2 micron 10K RE resistor is 2 millimeters long. Look down here. Look down here where the mouse documentation line is. Move over that. You can see it says that that's going to be 2 millimeters by 2 microns, so that's crazy. So I'm going to change that to a different type. Let me try this guy, RI. RI, it will be 11 microns by 2 microns, so that's pretty good. So let's label some inputs here. Let's call this in, and let's call this out, and let's just watch this thing work. So out, in and out. Now again, Derek, you set up all the simulations in the way you're used to doing it with ESS. So we'll have a debug underneath transient, and I guess some things for you. I'm going to say save all, and I'm going to say, for example, step with 1 nanosecond to 100 microseconds. Put a voltage source on in, between in and 0, nominally 0 volts, but a pulse that goes from 0 to AVCC after 1 microsecond, I don't know, I'm just guessing here, right? So look, I generated a pulse on that point. And that's all we need to do. We just now go to the run under here, and the run just says run, but I'll ask it to plot the output when it's done. Plot. Now in ngSpice, you don't say V out, you just say out, plot the output. Okay. So let's have a look at what's going on. This is one of the most important buttons on the schematic, this little guy here, which changes the configuration. This netlist, click on netlist, that's the netlist that this has generated. And just, go to the simulate tab and just hit go, and it'll run. That stuff's old from before. So that is the, oh, didn't work. Let me see if I can figure out what went wrong. Typical example of what goes wrong. Let's see what's going on here. Plot this. That did do what I suggested. Again, Derek, if you run into problems, you can do things that like you're seeing me doing here. just to reset these window sizes and things. This is because I scaled it for this recording. Let's persist for a minute. That input did the right thing, but the output didn't, and I don't honestly know why. Let's find out. Oh, it did. So what did I do wrong here? What was wrong with this plot out statement? Oh, it doesn't like that. Am I wrong? Do you have to do plot v out? Try that. Yeah, that works. Yikes. Okay. So let's run it again. Let's change the size of this device. Let's put 12 of them here, and let's hold on to that output, for instance, and do it again. Now look, we're getting down to 6 volts. So you know something's happening here, right? We're changing the thing. So the simulator is working, and you can click on things. Just click right and set plot. I made that device, 12 times. That input signal, that's the gate there, going up to 0.7 volt. That little marker tells you where it is. You can see down here, that's 900 millivolts. We're driving that pretty hard, or the base resistance is quite high. And all the other stuff should work. So for example, if you add a capacitor, this is the capacitor that the tool that in your kit, meaning this capacitor, which looks a bit funky like that. Move over, hit the tab key to rotate it. That capacitor is your real capacitor. By that I mean it is this netlist. Let me just show you what I'm talking about. There is your capacitor. If I just extract that again, sorry. There it is, look, CM model. I need your feedback on this, Derek. I had to modify that model. It was miles out. I believe they don't use this process very much because there's a clear error in that capacitor model which I fixed. I can explain that to you in some detail later. But so let's run it again now. We'll clear this guy away and clear this guy away just to see what's going on. Plot V out, and then underneath plot V in, and see what's going on here. There you go. Now that output now has got a kind of finite rise and fall time on it. I don't know whether I trust that though. Some funky things going on there. Let's make that into 100 picos. Instead of 10 picos, hit it again. Yeah, I guess. If it were me, I would slow down, get a few more data points in here. You have to watch this, Derek. It's not, a slam dunk, this Smart Spice stuff. I don't think there are sufficient time points there to justify that edge being as complex as that. But maybe I'm wrong. Double click on there, by the way, and drop lines. You can see the actual time. Oh, look, it didn't do too bad. It was working on that edge a lot there. But yeah, so anyhow, there you go. So the process is integrated now, and you just choose it from there. Now tomorrow, I will add the 36 volt process. Well, now that I've got this thing in place, it's not very difficult to add the 36 volt one. And I think you're familiar with the rest of the schematic. I don't need to tell you about it. Hit this button here, restart Smart Spice from NG Spice from scratch. NG Spice just trashed and restarted again. Hit the play button and it should just work again. And it does. It's very quick, as you can see. Just for fun, let's make that 1K. If that was 1K, that resistor, no, I can't do it. 1K is too small. Change the type of that guy to something that where it's a reasonable size. That's 200 micron. Okay, let's hit that one, see what we do now. It should be running a lot faster. Yeah, it is. So, it's hanging together. All right, sorry for the long monologue, but, significantly improved from what you were doing last time, Derek. Bye for now.